Most of us think we know exactly how to use a plunger.
Oh, absolutely. It
Yeah.
feels pretty self-explanatory.
Yeah, exactly. You grab it, you push it up and down over a stubborn drain, and, the clog magically disappears. I mean, it is just this universal domestic ritual that we all go through.
Right? But it turns out, because of one tiny, totally hidden detail in your bathroom, you have probably been plunging your sink completely wrong your entire life.
Which is wild to think about. So today, we are going deep into the hidden ecosystem right behind your drywall and under your ceramic basins.
Yeah.
We are looking at a masterclass video from Claude Taylor's How to Plumbing channel.
Yeah, it's a really fantastic source.
It really is. He takes us on this escalating journey of home plumbing triage. We are starting with the absolute simplest tricks you can do with just a wet rag, and we're going to end up performing major, basically wall surgery.
Well, surgery is a good way to put it.
Right. So the mission of this deep dive is to demystify what is actually happening when your sink backs up. We want to give you the knowledge to handle it yourself, or, at the very least, help you understand the invisible world you are navigating in your own home.
And the value of that understanding becomes very real when you look at the economics of this situation. I mean, the source material points out that calling a professional drain cleaning service to simply clear a bathroom sink can easily run you up to $425.
Wow. $425 just for a slow sink.
Exactly. And that is just to address the clog, assuming no major structural repairs are even needed.
That is steep.
It is. But by mapping out the mechanics of a plumbing system today, you gain a deep appreciation for the diagnostic skills that money actually buys. And more importantly, you learn the physical realities of the pipes in your own home, which can potentially save yourself a massive, unexpected expense.
Okay, let's unpack this, because before we go tearing into walls or, buying specialized power tools, we have to start at the absolute front line of plumbing defense. The plunger.
Right, the trusty plunger.
Yeah, but getting back to that opening thought, plunging is almost always an exercise in futility for the average homeowner. Because, well, we completely ignore the physical design of the sink itself.
You are referring to the overflow hole.
Exactly.
If you look at almost any standard bathroom sink, right near the top rim, usually directly below the faucet, there's a small opening.
Right, that little hole that gets all grimy.
Yeah, that one. Its primary intended function is actually safety. It acts as an emergency escape route.
So it's not a vent.
No, not a vent. If you accidentally leave the water running with the stopper in, that little hole gives the rising water a secondary path down into the main drain pipe, which prevents the sink from overflowing onto your bathroom floor and causing extensive water damage to your home.
Which, is fantastic for flood prevention. But it absolutely destroys the physics of plunging. Claude points out that before you even think about pushing a plunger down, your very first step must be taking a wet rag and completely plugging that top overflow hole.
What's fascinating here is the fluid dynamics of a closed system.
Okay, break that down for us.
Well, a plunger is not a mechanical stick pushing a clog. It is a pneumatic tool. It creates a highly pressurized column of air and water meant to forcefully dislodge a blockage further down the pipe.
Right, all about pressure.
Exactly. But the foundational rule of pressure is that it will always seek the path of least resistance.
So if you don't seal that top hole, your pressurized column isn't a column at all.
Precisely. If you plunge without blocking the overflow, the downward force you generate doesn't travel down the drain to fight the clog. The air and water simply shoot back up through the path of least resistance.
Which is that overflow hole.
Exactly. You aren't exerting any meaningful pressure on the blockage itself. You are just moving water in a tiny, totally useless circle.
It is kind of like trying to use a bicycle pump on a tire that has a massive gash in the side of it.
That is a great analogy.
Right. Because you are doing the physical labor, you are pumping up and down, generating all this force, but the air is just escaping out the side. You exhaust yourself for literally zero result.
Yeah, it's incredibly frustrating.
But by sealing that overflow hole tight with a wet rag and making sure there's a little water in the basin to give the plunger something dense to push against, you close the loop. The pressure is trapped. It has absolutely nowhere to go but down.
It perfectly illustrates how a tiny bit of structural knowledge completely transforms a frustrating, useless task into a highly effective solution. You are leveraging physics instead of just blind effort.
So we have conquered the fluid dynamics. The pressure goes down. But let's say you turn the faucet back on and the water is still sluggish. The pressurized approach hasn't fully won the battle.
That means we have to move from fluid dynamics to physical excavation. We have to go directly into the anatomy of the drain to intercept the problem.
Time to get our hands dirty.
Exactly. And the source notes a staggering statistic for this specific scenario. In homes that are less than 10 years old, 90% of the time, the culprit causing that physical blockage is exactly the same thing.
Let me guess.
Hair, you got it. It is a massive accumulation of hair caught directly at the pop-up plug mechanism.
The pop-up plug being that stopper you pull up and down behind the faucet. It is basically designed as the perfect bottleneck for hair to wrap around.
Yeah, it catches everything.
Claude actually goes under the sink and completely removes the horizontal lever that operates the stopper. That way he can pull the entire plug out from the top, giving him a completely unobstructed, straight shot down the vertical drain.
Which is essential for clearing it properly.
But once we are under the sink looking at that lever, we encounter the J-shaped bend of pipe right under the drain. The J-bend, or the J-trap.
It is more commonly referred to in the industry as the P-trap, due to its overall shape when connected to the wall. And honestly, it is a marvel of simple, brilliant engineering.
Most people assume that curved pipe is just there to catch a dropped wedding ring, right? Or to provide an accessible spot to clean out debris.
While it does serve those functions, its primary job is profoundly tied to the actual habitability of your home.
Which sounds incredibly dramatic for a piece of plastic under the sink.
Mm.
But that curvature isn't just about catching solid objects. It is about catching liquid.
Yes. The dip in the P-trap is intentionally designed to hold a small reservoir of water at all times.
Okay.
Because the pipe curves down and then must travel back up a few inches before heading into the wall, gravity dictates that a small pool of water rests permanently in the bottom of that curve.
And what does that water do?
That standing water acts as an impenetrable physical barrier. It completely seals the pipe, blocking highly toxic, foul-smelling, and potentially combustible sewer gases from creeping back up the plumbing lines from the city sewer main or your septic tank and escaping into your bathroom.
Oh, wow. So it is literally a gas mask for your house.
Basically, yes.
It is somewhat unsettling to realize that the only thing standing between a clean, fresh bathroom and a cloud of toxic underground gas is like a 2-inch puddle of water resting in a plastic curve.
It really is.
It is a brilliant design. But because it dips down to hold that water, it naturally becomes the prime location for heavy debris, soap scum, and sludge to settle and harden over time. Removing and cleaning that P-trap is the inevitable next step.
Which brings us to the tools of the trade. Once he removes that P-trap, he needs to force the hardened sludge out of the curve.
Wait, I have to bring this up because it feels almost scandalous when you watch it.
Oh, I know what you're going to say.
We are watching a professional who charges upwards of $400 for this service. And what does he reach for to clean this crucial engineering marvel? A bit of tissue paper and a wire coat hanger.
Yep, a coat hanger.
He just shoves a wire coat hanger through the curve to push the gook out. That almost feels like a ripoff to a homeowner watching. Like, shouldn't he have some high-tech laser for that price?
I mean, it might look unrefined, but it highlights a core truth of mechanical maintenance. You do not always need a specialized, complex machine.
Fair point.
The geometry of a P-trap is tight and curved. A flexible, sturdy piece of wire is actually the geometrically perfect tool to navigate that bend without damaging the interior walls of the pipe.
So it's function over form.
Exactly. It is about using the right physical property for the job, regardless of the price tag on the tool.
Fair enough. So we've done everything right by the book. We used the wet rag to plunge properly. We physically pulled the hair monster out of the pop-up. We dismantled the J-bend and cleared the sludge with our highly sophisticated coat hanger.
A very thorough job.
Right. The pathway from the sink basin to the wall should be completely clear. We put it all back together, we run the faucet, and the water still backs up.
That is the worst feeling.
It really is. But the physical laws of plumbing tell us the problem has migrated. We are no longer dealing with a sink issue. We're dealing with an infrastructure issue.
This is usually accompanied by a very specific diagnostic clue. The source describes a distinct sound as the water slowly struggles to drain. A repetitive, hollow bloop.
Yeah, that bloop. If you are standing at your sink right now and you hear that gasping bloop sound, that is your house telling you that your plunger is not going to save you.
If we connect this to the bigger picture of how a house's plumbing system actually breathes, that sound makes perfect sense.
Breathes. What do you mean by that?
Well, your home's plumbing isn't just a series of pipes carrying water down to the sewer. It is heavily dependent on a network of air pipes. Behind your drywall, connected to your drain lines, are vent pipes that run vertically all the way up and out through your roof.
Oh, right. I always wondered what those little pipes on the roof were for. It is kind of like when you take a drinking straw, put it in a glass of water, and then put your thumb over the top opening.
Yes, perfect example.
When you lift the straw out, the liquid stays trapped inside because there is no air pressure pushing down on it. The moment you take your thumb off and let the air in, the water drops instantly. Your plumbing lines need that roof vent to let air in behind the water, allowing it to flow smoothly downward.
That bloop sound is the drain literally gasping for air. It tells a professional that there is a partial stoppage much deeper inside the wall infrastructure backing up toward that airway vent.
So the airway is blocked.
Right. The water is struggling to push past a deep clog, and because the airway behind it is restricted by the backup, the pipe has to gulp air from the only opening left, which is the sink itself. That gulping of air is the bloop.
Here's where it gets really interesting, because the source material takes a massive, terrifying pivot right at this moment.
It really does.
While Claude is under the sink, investigating where the pipe enters the wall cavity, he discovers something totally alarming. The drain pipe disappearing into the drywall is completely severed. It is broken inside the wall itself.
It elevates a routine maintenance call into an absolute structural emergency.
Yeah, no kidding.
The pipe had disconnected behind the drywall, meaning every time water was run to test the drain, it wasn't going down to a clog. It was dumping directly into the interior wall cavity. He could already see water damage beginning to affect the wood framing of the house.
Which means pouring chemical drain cleaners or furiously plunging would just be forcing caustic liquid directly into the wooden skeleton of the home.
Which is a disaster.
Right. So simple drain clearing is officially impossible. We have to breach the wall to rebuild the infrastructure. But the location of this break makes the repair a geographical nightmare.
The source details the unique architectural geometry at play here. This particular house is a split-level or bi-level home. This means the second floor is only situated about 3 to 4 feet higher than the main level rather than a full story up.
Right. And because the floors are staggered like that, the plumbing doesn't drop straight down in a standard vertical stack.
No, it travels sideways.
Claude traces the pipe from the bathroom and realizes the access point to cut into the wall isn't even in the bathroom. The exact location of the broken pipe is in the adjacent kitchen, directly behind a mounted microwave.
Incredible.
He literally has to uninstall a major kitchen appliance to fix a bathroom sink.
It requires an acute spatial awareness of the entire house's footprint, really visualizing how pipes travel through the negative space between rooms.
It's like X-ray vision.
Exactly. Once he locates the target area behind the microwave, he uses a template to mark a precise square on the drywall. To make the cut, he utilizes an oscillating multi-tool, which vibrates a flat blade side to side at incredibly high speeds.
He specifically mentions retiring his old-school keyhole saw for this task.
Yeah.
And a keyhole saw is basically a jagged knife you punch through the wall and saw violently by hand.
Yeah, which shakes the surrounding drywall and creates a huge mess.
Right. The multi-tool just glides through, creating a surgical, clean access hatch.
Precision is absolutely vital here because once he reaches inside that dark wall cavity, he has to perform chemical surgery on fixed infrastructure.
Sounds intense.
It is. He reaches in, tests the stability of the remaining pipe, ensuring he doesn't fracture another joint further down the line, and cuts out the severed section. The replacement requires a 1.5-inch 90-degree PVC elbow and a short 3-inch straight pipe segment.
Wait, I am completely stuck on the physics of this assembly.
Okay, what part?
If you have two rigidly fixed pipes buried inside a wall's framing, you can't exactly pull the wooden beams of the house apart to slide a new connector between them. How do you physically bridge a gap when neither side can move?
That is solved by a brilliant piece of hardware called a slip coupling.
A slip coupling.
Yes. Normally, a standard pipe coupling is a small plastic cylinder with a tiny ridge molded into the inside middle. You push one pipe in until it hits the ridge, then push the other pipe in until it hits the ridge.
Okay, that makes sense.
But as you noted, that requires pulling the pipes apart to make room for the coupling. A slip coupling, however, has no inner ridge. The inside is completely smooth.
Oh, meaning it doesn't stop halfway.
Correct. You can slide the entire slip coupling completely up onto one piece of the existing pipe, temporarily sliding it totally out of the way.
Oh, wow.
You then align your new replacement pipe perfectly flush with the old one and simply slide the coupling back down over the joint so it bridges the two fixed pipes perfectly.
That is incredibly smart for tight wall spaces. But you can't just slide it and hope it holds water pressure. You have to bond it permanently. And the chemistry of how plumbers join PVC pipe is completely wild.
It's fascinating chemistry.
Claude uses a bright purple liquid first, known as primer, but it isn't just a heavy-duty soap to wipe off dust, is it?
No. PVC primer is highly volatile chemistry. When brushed onto the plastic, it initiates a harsh chemical reaction. It rapidly heats and physically softens the surface layer of the PVC.
So it melts it.
Yes. By the time you apply the actual pipe cement on top of the primer, the plastic is in a slightly gooey, melted state. When you push the two pieces together, they aren't just glued like paper. The softened plastics mingle and harden together.
Wow.
It is a chemical weld. The molecules interlock, fusing the two separate pieces into a single, continuous, watertight pipe.
He also mentions a great technique during that welding process. Once you push the newly glued pipe into the fitting, you give it a slight quarter turn.
Yes, the twist.
That twisting motion forces the cement to smear completely around the circumference, pushing out any microscopic air bubbles or dry voids that could cause a leak later.
It is a critical detail for longevity. You don't want to be opening that wall up again.
Definitely not. Hold on, though. We are talking about chemical welds, highly volatile purple primers, and plastics melting on a molecular level. And earlier, he was cutting the broken pipe out with power tools.
Right.
How is a plumber safely executing all of this in a dark, tiny hole behind a microwave or huddled under a sink vanity without succumbing to the fumes?
The environmental hazards are significant. For the cutting process, inside the wall cavity, he uses a compact, one-handed reciprocating saw. A traditional long hacksaw simply cannot swing back and forth in a space that is only 4 inches deep.
Makes sense. But what about the chemicals?
Regarding the chemical vapors, the source is explicit about the dangers of using primer and cement in enclosed spaces. Active ventilation is non-negotiable.
So you can't just tough it out.
Absolutely not. You have to open windows, run exhaust fans, and ensure fresh air is actively circulating through the room. The chemical vapors from PVC primer and cement are heavy and toxic. They pool in low, enclosed spaces like cabinets and wall cavities, and they can rapidly overwhelm a worker, causing dizziness or even worse.
The stakes are incredibly high for a sink repair. But the surgery is successful. The pipe behind the microwave is repaired, structurally sound and chemically fused. The drywall is patched. We no longer have a leak destroying the house.
A major win.
But remember the causality of this entire journey. The only reason we discovered the broken pipe was because we were hunting for the deep clog, causing that gasping bloop sound. The airway is still restricted, so now, finally, we can clear the deep line.
This is where physical machinery comes into play. Plunging and coat hangers cannot reach deep into the subterranean infrastructure.
Time for the heavy artillery.
Exactly. Claude brings in a Milwaukee battery-operated sink drain machine. It is essentially a motorized spinning drum that feeds a long, highly flexible steel cable, the snake deep into the plumbing labyrinth.
It pushes it down, spinning it to chew through whatever is causing the blockage.
This raises an important question, however.
What's that?
When you are blindly pushing a 25-foot steel cable into a pitch-black pipe system, how does the cable know which direction to travel? When it hits a T-intersection in the wall, what prevents it from taking a wrong turn?
Especially considering the vent pipes we talked about earlier. Those go straight up to the roof. Yeah. You really don't want to spend 20 minutes feeding a motorized cable into the wall, only to walk outside and see it waving at the neighborhood from your chimney.
That would be a very bad day. The engineering solution is surprisingly elegant. It relies on a specialized attachment at the very tip of the cable called a drop head.
A drop head?
Yes. The drop head is a heavy, articulated, hinged guide. As the cable is pushed through the pipe, whenever it encounters a vertical intersection, the hinge allows gravity to instantly pull that heavy tip downward.
So instead of accidentally shooting upward into the dry vent pipe, the weight naturally drops it down toward the main sewer stack. Gravity basically does the steering.
Exactly. He feeds the drop head in, using his bare hands to feel the tension on the cable, sensing his way through the unseen elbows, and turns behind the drywall.
It takes a lot of feel.
It does. He eventually hits the deep restriction, the spinning cable breaks the clog apart, and he manages to feed out a full 25 feet of cable, reaching the main vertical stack of the house.
Awesome.
The deep labyrinth is officially cleared, the airway is open, the bloop is finally defeated.
With the deep infrastructure flowing freely, the final step is reassembly under the sink basin. But even in this final phase, there are nuances. Claude doesn't just put the old parts back. He upgrades the geometry.
He notes that many older lavatory sinks utilize a narrow drain pipe that is only 1¼ inches in diameter. However, modern residential plumbing standardizes the wall pipes at a larger 1½ inches to facilitate better water flow and reduce clogging.
To bridge that discrepancy, he uses a specific trap adapter and a specialized reducing washer. It is 1½ inches on the outside rim to perfectly fit the new wall pipe, but tapers to 1¼ inches on the inside to securely grip the older sink drain.
Which is brilliant.
Yeah, it maximizes the drainage volume while maintaining a totally watertight seal.
As he rebuilds the new P-trap assembly with these upgraded parts, he shares a surprisingly philosophical observation about the plumbing trade. It is the plumber's corollary to Murphy's Law. Anything that can go wrong will go wrong.
I love this detail. He mentions that plumbers always buy 2 of everything when they visit the supply house. They buy 2 cans of the volatile purple primer and 2 cans of glue.
Always.
Why? Because you're mathematically guaranteed to kick one over and spill it everywhere on the floor, so you always need the backup to actually finish the job.
It is so true.
It is that kind of hard-earned, boots-on-the-ground wisdom you can't learn from a textbook. He even admits on camera that during the final reassembly, he temporarily forgot to tighten one of the slip nuts on the J-bend. It is a great reminder that even the pros have to meticulously double-check their work.
Absolutely. No one is immune to mistakes.
So what does this all mean? Let's take a step back and look at the sheer scale of the journey we just mapped out. What started as the most minor domestic annoyance imaginable, watching toothpaste swirl lazily in a slow-draining sink, escalated into an architectural rescue.
We moved from manipulating fluid dynamics with a wet rag over an overflow hole to understanding how a tiny reservoir of water in a P-trap shields a family from toxic underground gases.
Right.
We learned to diagnose an infrastructure airway restriction just by listening for a gasping bloop. We mapped the unique geometry of a split-level home to perform chemical welding on a severed pipe hidden behind a kitchen microwave.
And finally, we navigated a dark 25-foot subterranean labyrinth using gravity-assisted drop heads and motorized steel cables.
It perfectly illustrates the true value of expertise. When a professional hands you an invoice for $425, you are not paying them for an hour of physical labor. And you certainly aren't paying them to jiggle a plunger.
Definitely not.
You are paying for a lifetime of spatial reasoning. You are paying for the diagnostic ear that instantly recognizes what a bloop means. You are paying for the chemical knowledge to safely fuse volatile plastics in an unventilated space, and the mechanical intuition to steer a blind cable safely through the fragile, invisible infrastructure of your home.
It is a profound shift in perspective. You stop viewing a clogged sink as a simple nuisance and start seeing it as the tip of a highly complex, engineered system. Which leaves me with a lingering thought for you to ponder long after this deep dive is over.
What is that?
Next time you encounter a minor everyday annoyance in your home, maybe it's a bedroom door that suddenly starts sticking in its frame, a light switch that flickers for just a millisecond too long, or, yes, a sink that is stubbornly slow to drain.
Okay.
Ask yourself, is this really just a minor quirk of an old house? Or is it the only visible symptom of a complex, invisible system quietly failing just behind the drywall?
That is a question that will definitely change the way you listen to your house.
It certainly will. Keep an eye on those overflow drains, everyone. Until next time.